Hi everybody, this is day 4 of the semester 1 final exam review for geometry. Alright, let's give this first problem a try. They say in the prompt that line segment DE is parallel to line segment BC. So I'm going to add in those little carets to show that they are parallel. Now they would like us to find the values of x and y. So the first thing that I notice here is that we have a triangle. So I'm actually going to ignore line segment DE. So we know that according to the triangle Sum Theorem, the three angles in your triangle should add up to 180. So I can create an equation that looks like this: 25 plus 85 plus x equals 180 degrees. So let's combine like terms and solve for x. So x is going to be 70 degrees. So now that we know what x is, we can find y. So here we're going to use the two parallel lines cut by a transversal. So you can see that the relationship between the two angles here and here is consecutive interior. And we know that consecutive interior angles are going to be supplementary, which means that they add up to 180 degrees. So we can use that fact to help us set up an equation. So we know that x plus 25y minus 15 should equal 180. We can substitute for x, which we know is 70. So we can say 70 plus 25y minus 15 equals 180. Now we can combine like terms. So we get 25y plus 55 equals 180. Now we're going to subtract 55 from both sides. And we get 25y equals 125, which means if we divide both sides by 25, we get y equals 5. And that's just part of a bigger degree, so I'm just going to leave it as 5. Okay, in this problem, we are told that the measure of three interior angles of a triangle are x, 5x minus 8, and 4x minus 2. What type of triangle is this? So the first thing I want to do is talk about the different types of triangle. Here we are given the angles, so there's a way that you can describe them by angle. So the three types of triangles that we can see are acute, obtuse, or right. So acute, of course, means that all angles are less than 90 degrees. An obtuse triangle is where one angle is greater than 90. And then a right triangle is where one angle is exactly 90 degrees. So we're going to need to actually know what the angles are. So I'm going to just set up a picture, and we're going to solve for x and actually figure out what those different angles are. So we know, as we just talked about, that the angles of a triangle should add up to 180. So we can say x plus 5x minus 8 plus 4x minus 2 equals 180. So let's start by combining our x terms and now our numbers. We can add 10 to both sides. And if we divide by 10, we get x equals 19. Now we're going to take this x value and we're going to go back and substitute it and to see what kind of angles we get. So I'm going to call this angle A and B and C. So we know that angle A is just going to be 19 degrees because it's only x. Now let's find angle B. It's going to be 5 times 19 minus 8. So we get 95 minus 8, which is 87 degrees. So now we know, we know angle A, we know angle B. Now let's find angle C. So angle C is 4 times 19 minus 2. So we get 76 minus 2, so angle C is 74 degrees. So if you look at all three angles, all three of our angles are less than 90 degrees. All angles are less than 90 degrees, which means that this is an acute triangle. So this problem does have quite a bit to it. You have to first solve for x, and then you have to substitute your x values to actually figure out what your angles are, and then you can decide what type of triangle it is. Okay, let's move on to this next problem. Here they ask us to find the measure of angle C. So we're going to work our way over. So I know that this angle right here is going to be 50 because these are vertical angles and vertical angles are congruent. And then I see that we have a nice triangle. And I'm going to call this angle X. And we know that the three angles of a triangle should always add up to 180 degrees. So here we have X plus 115. Oops, that's not a plus sign. Equals 180. So we get X equals 65. And we'll say degrees. And that is angle C. All right, here. We are told that triangle HAT is congruent to triangle BIG. What angle corresponds with angle A? So remember, when we are told that two triangles are congruent, the corresponding parts are listed in order that they name the triangles. So H will go with B, A goes with I, and T goes with G. So it matches the order. So which one corresponds with angle A? That would be angle B. Or sorry, angle I, the one in the middle. There you have it. Okay, this problem they say, what is the vertex of an isosceles triangle with, the vertex of an isosceles triangle is 100 degrees. What is the measure of one of the base angles? So here, we need to remember what isosceles means. Isosceles means that two of the sides are congruent. So we can draw a triangle that looks like this. And there are specific parts of an isosceles triangle. So these would be your base angles. So your base angles are always across from your congruent sides. And the angle that's between your congruent sides is called your vertex. Now, another nice thing to note about isosceles triangles is since the sides are congruent, the angles opposite them are also congruent. So that's always going to be true. So it says if the measure of the vertex is 100 degrees, what is one of the base angles? Well, since they're congruent, we can call them both x. So we're essentially just solving for x. So we can set up our equation using the triangle sum theorem. They should all add up to 180. 2x plus 100 equals 180. 2x equals 80, so x must be 40. So 40 degrees is our answer because that is one of the base angles. Okay, in this problem, they want to know the length of the sides of this equilateral triangle. So equilateral is another type of triangle. An equilateral triangle is a triangle where all sides are congruent. So in this picture, I know that all three sides are congruent. So since they're congruent, I can set any of them equal to each other to solve for x. So I can pick this, 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 and this. It doesn't matter. So let's say 5x minus 3 equals x plus 33. So I'm going to subtract x, and then I'm going to add 3 and divide by 4. So we get x equals 9. But they don't want to know what x is equal to. They want the length of a side. So I'm going to need to substitute that into any of my sides. It doesn't matter which ones because they are all the same. So let's substitute it into x plus 33. So we have 9 plus 33, which is 42. And if you substituted it here or here, you would get the same exact answer. All right, so let's look at this next problem. It says, in the figure below, what piece of information is needed to prove that the two triangles are congruent using the ASA congruence theorem? So remember, ASA stands for angle, side, angle. And it needs to be in that order. So let's look at what we are given or what we know just by looking. So we know that angle R is congruent to angle T because they both have the double arc. We know that angle W is congruent to angle V. So what we know is angle and angle. So you can see that we're missing that side in between. So we have to describe that these two in-between sides are congruent. So we can say RW is congruent to TV. So that's the piece of information that we are missing in order to use ASA congruence theorem. All right, here's another similar problem. What piece of information is needed to prove that those two triangles are congruent? But this time we're using side, angle, side. SAS, side, angle, side. So let's see if we have any of that information. Let's see what we are given just by looking at the picture. So I know that actually this line, BD, is part of both triangles, and it is the same length, so we can actually say that it's congruent to itself. So that's something to look out for. So BD is congruent to BD. That's going to be one of our sides. Then I also see here that we have a 90-degree angle. If this is 90 degrees and this is a straight line, we know that this is also 90 degrees, so the two angles are congruent. So we know that angle ADB is congruent to angle CDB. So that's the angle. So we are clearly missing the last side. So if you were going in that order, we would see that it needs to be this side, AD, and this side, DC. Those need to be congruent. So that's our missing piece of information if we want to use side, angle, side. All right, here we're asked to determine whether the following sets of numbers can be lengths of sides of a triangle. If not, we're going to state why. So the idea is you can't just take any three numbers and have them work for a triangle. The way you check is if you add up two sides of your triangle, it should always be greater than the third side. So we're going to add up the first two, and then let's add up the second and the third. And then let's also add up the last and the first. So that's all of the possible combinations. So let's see if all of those inequalities are true. So here, 17 is greater than 8. So remember, this symbol means greater than, which is just bigger than. So this is a true statement, so that one works. Here, 20 is greater than 5, so that works. And here, 13 is greater than 12. So those three, yes, they could be the sides of a triangle. Let's check this next one. So let's set up our three inequalities. 14 plus 8 must be greater than 2. 8 plus 2 must be greater than 14. And 2 plus 14 must be greater than 8. So let's check. For this first one, we get 22 is greater than 2. That is true. Here we get 10 is greater than 14. So this is not true. So I don't even need to check that last one. I know that no, this can't be a triangle because 10 is not greater than 14. And this last one, let's set up our three inequalities. Then 10 plus 12 is greater than 22. And 22 plus 12 is greater than 10. So here we get 32 is greater than 12, so that one works. But here we get 22 is greater than 22. Now 22 is not greater than 22, it's equal to it. So it only works if the value is greater. So no, because 22 is not greater than 22. And now we're done. Okay, this is the last problem. So here it says, if DB is a median, what other statements can you make about the figure? So it's really important to remember what a median is. So a median has a very specific job. A median bisects the opposite side. That's its only job. It's the only thing it does. And remember, bisects means cuts in half. So let's look at our figure. If BD is the median, so it's going to bisect AC. So it's going to create two congruent parts. So one true statement I can make about this figure is that line segment AB is congruent to line segment BC. Now, this is actually the only true statement we can make. So I know that it looks like these two are congruent, but they're not. That would be an angle bisector. So a median's only job is to bisect the opposite side. So make sure that you are only going by information that you know for a fact and not just using how your figure looks. So you have to know what your different line segments will do to your triangle. All right, that is all for today. Thank you for watching.